Good day, everyone. My name is Suleiman MSK. Today, we're going to discuss physics. In the last episode, we talked about motion, where we're able to derive the three equations of motions. Today, we still have to derive the various equations of motions, but using graphical method. That's velocity time graph physics. Motion. Velocity time graph. In the velocity time graph, we have the coordinates. That is the y and x axis. This is y, this is x. Supposing a car starts with a velocity u and attained a velocity v, so u stands for the initial velocity. We know velocity is the rate of change of displacement, and we say velocity is a vector quantity with respect to time t. Using these parameters, u, v, and t, we can be able to derive all the parametric equations of motion. The first one, considering the straight line uv being a straight line, then we can be able to determine the acceleration. Since there is change in velocity, if you can remember very well, we said acceleration is the rate of change in velocity with respect to time. So in this case, we have acceleration A equals to change in velocity with respect to time. So the acceleration here will be the change in velocity will be equals to, look at the time here at the same time, t, the time taken, which is equals to v minus u over t. Meanwhile, the acceleration will then be equals to v minus u over t. So making v the subject, we have this implies that v minus u equals to at. Then so therefore, then v would then be equals to u plus at. This is the first equation of motion. Secondly, what is the total distance covered? If you look at this graph very well, from plane geometry, the shape of this curve or the shape of the graph is trapezium. Supposing we name it as A, B, C, D. This is a trapezium because AD and BC are parallel sides. And parallel lines are lines that they can never meet no matter how long they are. So in this case, suppose we call this the first one. Number 2, total distance covered. Total distance covered is equals to area under the curve. Area equals to area under the curve. Under the curve. And the area under the curve, the total distance covered S equals to area of trapezium. Area of trapezium. So then the total distance now S will be equals to area of trapezium is always defined as half the sum of the parallel sides times the perpendicular height. And this height is the height in between the parallel side, and the height here is t. So in this case, we have half into sum of parallel, the symbol of parallel sides, multiplied by the symbol of perpendicular height. So the total distance covered will be equals to half into the parallel side. The first one here is from point A to the initial velocity, which is u, plus from point B to the final velocity, which is v, then multiply by the perpendicular height between the two parallel sides, which is t. All right, but from equation 1, we get to know that v equals to u plus at. So we substitute here that S equals to half into U plus, in place of V, we have U plus AT multiplied by T. So now, the coefficient of this bracket, first of all, we have half, we have T, that is half T. So let's multiply, or let's first of all simplify. S equals to half into U plus U. That is 2U plus AT multiplied by T. Now, to be on safe side, let's multiply T into the terms within the brackets. First, we have S equals to half into 2UT plus AT times T, that is AT squared. Then finally, we multiply the coefficient of the brackets with the term within the brackets. So at the end of the day, we have S equals to half times UT. That is, since this is the inverse of this. So at the end of the day, a number times its inverse is unity. We have UT. Then plus half times AT squared, we have half AT squared. This is the second equation of motion. In the second equation of motion, we have S equals to UT plus half AT squared. Then, to derive the third equation of motion, suppose you say from 1. From 1, that is 1 is V equals to U plus AT. If you decide to square both sides, square both sides, we then have V squared equals to, open bracket, U plus AT all squared. The problem is, how possible can we be able to expand U plus AT all squared? It's as simple as this. Since we only have two terms within the bracket and the degree is 2, then in the simplest way, just use the power and attach to the first term here we have U squared, that is 1. Secondly, use the power to multiply all the terms within the bracket, taking advantage of the sign. The sign here is positive. We have 2 times U, 2U, times AT, 2U, AT. Finally, we repeat as we started from the first time. That is, you now attach the power to the last term. That is AT squared. That will give you A squared, T squared. All right. Then we now try to factor out the common term. We have V squared equals to U squared. In this case, we have 2U or 2A, let's say plus 2A into, first of all, 2 cancel 2, A cancel out A, leaving behind UT. We have UT, then plus, in this case, there is no 2 here, at the same time, to factor out 2 here, then we multiply by its inverse. That is half, 2 times half is unity, A cancel A, leaving behind AT squared. So at the end of the day, we have V squared equals to U squared plus 2A from equation 2, V squared plus, from equation 2, we get to know that UT plus half AT squared is something as S. All we need to do is to substitute the last part of this expression with S. So in this case, this is the third equation of motion. In the third equation of motion, we have V squared equals to U squared plus 2S. Meanwhile, V stands for the final velocity, U stands for the initial velocity, A stands for the acceleration, S stands for total distance covered. So let's take one example in such a way that students can always try to know exactly when to use either of the 3 parametric equations. That is the first one, V equals to U plus AT. The second, V squared equals to U squared plus 2AS. The third one, S equals to UT plus half AT squared. All right. So example comes here. The first one says a car accelerates uniformly. A car accelerates uniformly at a rate of 10 meter per second square from an initial velocity of 36 kilometers per hour for 30 seconds. First off, we are now asked to find the distance covered. Find the distance covered during this period. Okay, let's go for break. When we come back, we handle this discussion with ease. Thank you for watching. So welcome back, everyone. So earlier before the break, we derived three important equations of motion. V equals to U plus AT, V squared equals to U squared plus 2AS, S equals to UT plus half AT squared from graphical method. And we have a very simple question that I would like us to analyze before we start solving. The question says, a car accelerates. Look at these terminologies. If you can remember from the beginning, we said acceleration is the rate of change in velocity with respect to time. And acceleration is a vector quantity, simply because it has both magnitude as well as direction. So uniformly, being uniform acceleration, that means that whenever the body or the velocity changes by equal amount in equal time, no matter how small the time may be, then the acceleration is said to be uniform. Look at this. Uniformly at the rate of 10 meters per second squared. So the solution comes here. That tells you that A equals to 10 meters per second squared. That is the first parametric equation. Then the second one says from an initial velocity of 36 kilometers per hour. Then we have U equals to, U stands for the initial velocity, 36 kilometers per hour. So the problem here is that since acceleration is given in meter per second squared, that is meter and second, then initial velocity in kilometer per hour, you must convert the kilometer and hour to SI units. That is, so this would be the same thing as 36 times 1,000. Kilo means 1,000. Then per hour, per divided by, we all know that 60 minutes make 1 hour. And 60 seconds make 1 minute. Then we multiply by 60 by 60. So this is now in meter per second. At the end of the day, have your U will then be equals to, if you should cancel out, cut this, 0, cancel 0 here, and that 0 cancel this, be left with only 36 times 10, that is 36 times 10, all divided by 6 by 6, still have 36. Then 36 cancels 36, so the U now would be equals to 10 meters per second. That's the initial velocity. So, for 30 seconds, very, very important, 30 seconds, the time here is given in seconds, so we have the T equals to 30 seconds. So the question comes this way. We are asked to find the distance covered during this period. Find the distance covered So the distance covered there is s, is unknown. So having known the acceleration 1, initial velocity converted to meter per second 2, the time taken 3, we can be able to calculate the value of the total distance covered. So all we do, we now refer back to the parametric equations of motion, where we have A is given, U is given, T is given, and the distance. The first one, we have final velocity. Final velocity is not given. In the second one, we still have final velocity. We don't have final velocity in the parameters. Then the third one, suppose we say now, using S equals to UT plus half AT squared. This can solve this problem with ease. Okay, S equals to UT plus half AT squared. S stands for the total distance, U, initial velocity, T, time, A, the uniform acceleration. So here we have S, which is the unknown, equals to U. U is the final velocity, which is 10 times T is given as 30 seconds. Then plus half times acceleration A is given as 10 meters per second squared. Then times 30, T is 30 seconds. Then 30 squared. So to simplify this now, you have S equals to 10 times 30. That is 300 plus half, 1 and 2 into 10, 5. So here we have 5 times 30 squared, means 30 times 30. Or you can easily say 3 squared, 9. This is squared, you add 2 zeros. That is 900. So at the end of the day, we have S equals to, in both mass. Please do not add while you're having multiplication. Remember both mass from mathematics. If you decide to add, right from this point, you fail the solution. You multiply first before you add or subtract. So what we do here, we take 300 plus then 5 times 900. The best way to handle this is 5 times 9 is 45. Then you write 45, then you have 2 zeros. Then 1, 2. So S will then be equals to 300 plus 4,500. So this will give you 4,800 meters, since we've converted all the units to SI units. But this is large. And at the same time, since the initial velocity is given in kilometer per hour, so there's a need for you to convert this to kilometer. Kilo means 1,000. To round it up this way, we have 1, 2, 3. Then preferably, the total distance will be equals to 4.8 kilometers. Since kilo means 1,000, it's as if you divided 4,800 meters by 1,000. So this is exactly the total distance covered from the question. Let's go back to the question again, because with little idea on how to extract parameters, then you should be able to solve as many numerical problems as possible related to equations. The first, look at say a car. Not only a car, it could be a particle, it could be a body. The most important is what are the parameters. A car accelerates uniform. Accelerate, acceleration. Then you write down value of A, and that acceleration is given as 10 meters per second squared. Lucky enough, the unit is given as SI units, so I don't have a problem with this. Then another parameter is from an initial velocity of 36 kilometers per hour. So we have initial velocity. The problem is this is given in higher unit. So we decide to convert it to SI units. 36 kilometers per hour. The kilo we multiply by 1,000. Per hour, we convert it to minute, from minute to second. Converting to minute, you multiply by 60. Converting to second, is still multiplied by 60. At the end of the day, this is now 10 meters per second. And the time, which is very, very important, the time that this event occurs takes 30 seconds. That is t equals to 30. So the question now is, find the distance covered during this period. Distance, which is s, is unknown. Then, using 1, 2, 3, 4, then I will now search from the 3 equations of motion. Which of them satisfy this? S equals to ut plus half at squared. We haven't known this, then you're almost a winner. All you need to do, you substitute your values into your parametric equation and simplify the equations one after the other with ease. At the end of the day, you should be able to arrive at the final correct value. So thank you for being part of the program. Thank you for watching. See you next time.